So moving away from dimension stone, right? So either blocks of stone or slabs of stone. I guess I didn't even get into headstones. That's its own kind of industry, but it's not too dissimilar from slabs. It's just a little more specialty. The next usage of stone that we're going to talk about is aggregate. And aggregate is keyword for sand and gravel. So small, kind of crushed up things. So sand and gravel or aggregate by volume is the largest traded geologic material in any given year. We use lots of it. The reason we use a lot of it is that its uses are kind of all over the board. And some of them are really fundamental to us building, right? We use it a lot, oftentimes in construction. In many cases, sand and gravel is also not super rare. We need to use it for kind of road beds. And oftentimes, if the Idaho Transportation Department is, putting in a new section of road, they may actually develop a small borrow pit or a small quarry locally that they can pull enough gravel out and use, or maybe they have to crush it and improve its shape a little bit. Then they can use that for the roadbed. And when the road's finished, they'll do the kind of remediation on the quarry and move on. Right? So there's plenty of it around. If you don't have some around, you might bring in a rock crusher and make your own from the bedrock in the area. Again, kind of environmental permits allowing. So thinking about what we use sand and gravel for, if we think about sand and gravel, its primary use is actually construction, roadways, foundations, all of that stuff. We do have some cases where we'll develop French drains, like you dig a hole and fill it with gravel and water pours into there and will infiltrate. So we use it for drainage. We mix it with tar, right? So the stuff that comes off the bottom of the fractionation column in the process of oil refining. We mix sand and gravel with that to make asphalt. We mix sand and gravel with this material called lime or cement to make concrete. We take sand that has a large grain size variability, so ranging from small to large, and also we hopefully can find angular pieces. We use that to make foundations for roads and things. It holds its shape really well, what we call road mix. All sorts of different uses. So generally we extract this material. We don't want it to be lithified. We just go and get the sand and gravel, hopefully from a floodplain or an alluvial deposit. So I've drawn this little valley here. Let's say we've got a stream. It has some gravels and sands and stuff. If this is a meandering stream, what it's going to slowly do over time is kind of work its way back and forth on its own floodplain here, resulting in this very flat feature, meaning these deposits are also sand and gravels. There's actually a really great example of what some of these types of deposits look like just below Lucky Peak Dam across from Discovery State Park. There's a great section of some sedimentary rocks exposed there, and you can see what that sand and gravel looks like. So we've got sands and gravels on these alluvial surfaces, right, meaning deposited by water. And a couple of different things can happen. So locally, one of the things that we've had happen is the river will downcut and leave these river terraces behind that are filled with sand and gravel and develop a new floodplain down at a lower elevation. So if we wanted to recover some sand and gravel, we could actually go to one of these terraces. There's about 6 of them in the area, and we could recover that material and sell it. Again, there's no technical mining here. You're really just going in and taking the sand and gravel. You generally have to sort it, right? So you get different sizes of big sorting kind of sieves and machines. Or we could also take it closer to the river. In an active floodplain, we could get the same sand and gravel. That's a little bit less, in the kind of modern world, this is more problematic because it's closer to the river and there could be some ecological repercussions. Historically, that's actually what we did, specifically in Boise. And actually, if you follow the Boise River along, you can see these, especially out by Eagle, these huge lakes all over the place that were gravel pits at one time. But I want to take a look at here. So farther out, and here, again, I'm going to try to do this Google Earth thing. So I'm not looking at it, but I'm trying to remember it. If you're at the Boise airport, If you're driving in from into Boise from Mountain Home direction, there's actually a whole bunch of these old gravel pits. You can see some of them are still active. Here's some active. One of them is a place where you can dump off your leaves. But as we kind of pass through the Boise airport and actually go to the south of the Boise airport, this is a river terrace of the Boise River called 10 Mile Terrace. And this was one of the largest sand and gravel operations in our area, although they're strung out all over the place, right? They actually follow these terraces along the whole valley. Actually, so I'm out at CWI's campus in Nampa today. Just across the freeway, there's a gravel pit that you can see as you're driving home. And we'll actually mention, because one of the things they're doing there is actually making concrete. So we'll loop back and talk about that. Sand and gravel is big business. And one of the weird, kind of like the ironic things is to have sand or a road mix that really meets the purposes for construction, it has to have a large grain size variability, and those grains need to be fairly angular. So if you think about a place like the Sahara Desert, right, in Egypt, the sands in Egypt are all moved around by wind, meaning all of the grain sizes are almost uniform. We call that very well sorted. And because the wind is moving them around, they're almost all shaped like little BBs. They're perfectly round. And that will make a terrible structure. So places like that, for construction purposes, and also for things like sandblasting, they actually have to import sand from more northern climates, from Europe or from India, from northern India. And it can be a pretty big problem. And so actually, speaking of India, one of the things that's currently happening there is because there's so much building going on, the type of sand that we need for construction is so hard to come by that there's a lot of illegal sand mining that happens, right? So the sand mafia and the sand cartels that are producing these, illegally producing the right type of sand and selling it to construction companies so that they can finish their projects. And sadly, it's bloody, right? So you may be a landowner, but part of your land is sand. These people don't want to pay you for it. And there's been kind of death and destruction all tied in with the sand mafia or the sand cartels. But that's, it's its own wormhole that you can go down if you go onto YouTube and look up the sand mafias in India. There's all kinds of cool documentaries. So just to give you some round numbers, when we think about, I talked about sand and gravel being the most widely traded by volume geologic resource. So financially, on an annual basis, it's a $6 billion industry. That number, $6 billion, is big. But if you've ever bought a yard of road mix, it's not very expensive, right? So when we think about $6 billion for something that's actually fairly cheap, we're talking huge volumes. Kind of a standard year, thinking about sand and gravel business, 800 million tons per year would be a pretty average amount of material to move. 800 million tons. That's huge. The price isn't very high, so that's at $7.50 per ton, kind of bears out that $6 billion figure. So we're talking huge volumes, but for smaller projects, it's actually not super expensive at all. For the last section in sand and gravel, I kind of wanted to talk about some specialty or one specialty type of material, and this is volcanic derived gravel, pumice. And so pumice is a volcanic rock that's solidified magma froth, if you were to think about it that way. So again, if you're more interested, if you want to learn more about volcanoes, take my physical geology class. We'll talk about them a lot. But what pumice is, if you were to imagine a cappuccino or something, that's really frothy, or the head of a beer or something like that, and you were able to take that frothy material and kind of instantaneously solidify it and crush it into gravel-sized pieces, that's what pumice is. And you're probably familiar with this, right? You might have a scrubber that you use to get the skin off of your feet, or whatever in the bathtub. I know that there's a pumice piece in my shower, and it's one of the rocks in my house that I had nothing to do with, on the bottom of your feet. So here you can see this is a picture of pumice in a SEM, so scanning electron microscope, and it's volcanic glass. It's just full of little bubbles, so it's sharp like glass, and it's really abrasive. So we can use it for those sorts of purposes. But additionally, it's filled with air bubbles. So pumice will famously float in water, which means it's lightweight. It's like nature's closed cell foam, right? So it's all these little air bubbles, air pockets, but they're not connected to one another. So pumice is also remarkably lightweight, right? Even you can pick up a giant piece of pumice and look like you're, Hercules, but you're actually picking up a fairly lightweight rock. And that has some advantages. So one of the things that we have really done for a long time now is we'll take that pumice, or another kind of term that people might use for these, particularly if they're black or more mafic, would be cinders, but generally we actually do this with pumice, and mix it with a slurry of concrete. So now the gravels contained in the concrete are actually full of little air bubbles. And as we incorporate that and form the concrete, the gravels are making that much lighter. And so you've heard of the term cinder block, or a CMU. It's actually crushed up pieces of pumice slurried with cement that are pressed into those forms that we use for building all kinds of stuff. So that helps them be more lightweight. And kind of further, there's some interesting technology and kind of ideas being batted around of how to do this without adding cinders, or adding pumice, which is essentially like carbonating or adding a chemical to the cement to make it fill with its own air bubbles. And it makes the cement go farther. It makes it a little bit less strong, but it's one of the ideas being proposed on how to build facilities in space, right? So if you go to Mars, your concrete doesn't need to be as strong because the gravity's not as strong. So you can kind of carbonate, in a way, your concrete and fill it with air pockets. And that might be a way that we could make our building materials go further as we're potentially building things in space, which is pretty crazy.